There's our first derivative. And so we find the critical points here by setting that equal to 0. So I'm looking to pull a 4 out of each one of these numbers. And since they all have at least one x, I'm going to factor out an x. That leaves me x squared minus 3x minus 4. So I already know 0 is a solution from that, or one critical number. So now I'm going to try to factor what's in here. I know I'm going to put an x in each one, because x times x is x squared. I need to make 4, but adding and subtracting the combination that I'm using, I need to get 3. So I can tell that's going to be minus 4 plus 1. Okay, because the 3 is negative, so I want the larger number to be negative. And then when I add 1 to that, it will give me negative 3. And negative 4 times 1 is going to be my negative 4. So from here, I also know I'm going to have solutions of negative 1 and 4. So those are critical numbers that we're going to test, remember, and see which one has the largest or smallest value. So I'm going to go ahead and take the second derivative. Okay, so I'm going back to this, and I'm going to take the second derivative. And Luna's getting ready to come help me. So that's 12x squared. I don't know what you want, sweetie. 24x minus 16. Okay, so we're going to solve that. And I'm going to, oh, don't step on anything, please, sweetie. I'm going to pull, I can't think now, 4. Yeah, we're going to pull 4 out of there. So I have 4. That's going to be 3x squared minus 8x minus 4. I don't remember it being this complicated. So did I mess something up since Kitty walked through? Nope, that's good. Let's see. So let me check the answer. That's just a hard one to factor, is why I'm checking myself. Oh, I'm making it harder than it needs to be. You don't do the second derivative. You're probably thinking about that yourself. Okay, so basically what we did was we took these numbers and the ones that it gave us, -1 and 5, and we plugged them all in. Right? Right. And then found the F max and the F min at 0 and 4. Okay, you got it. Here we go. So here's our implicit differentiation. This is that dy dx portion. And so let's rewrite this. X to the 1/2 minus y to the 1/2 equals 10. So when we take the derivative of that, actually, I guess we write dy dx. Erase. Okay, that doesn't want to go away. Oh, there it went. Dy dx. So 1/2 times. Then I subtract 1 from this. That's going to give me a -1/2. Minus, I do the same thing with the y. So it's 1/2 y to the -1/2. But then here's where I add the dy dx. Okay, so now we have to solve. This does not have a dy dx. This is negative, so I'm going to go ahead and put it on the other side of the equal sign. Now I want to get dy dx by itself, so I'm going to divide by this. So I'm basically going to have a very complicated thing that we're going to simplify using the trick that I showed you. Okay, so I'm thinking about this right here, and I'm writing it like this: 1/2 divided by 1/2. Okay, so 1/2 divided by 1/2 is 1. Okay, and so we literally have these, but because they're negative, they switch spots. So basically, it would be the square root of y over the square root of x. Okay, and that equals dy dx. So then you put the 2 in the 2. Oops, wrong problem. That's all you have to do. Okay. Then the next one, dy dx. So let me erase this. We're doing the same thing. However, we are plugging in values when we get done. This just does not want to erase. It's moving slow. My computer does not like PDFs for whatever reason. Okay. So 3y squared, okay, that's our dy dx, equals 3y squared. And we're messing with y, so we put on our dy dx minus 2y dy dx minus 1, but we have to add the dy dx, equals 1, because if you differentiate x, it just goes to 1. So I'm going to divide dy dx out of all of these things, and I get 3y squared minus 2y minus 1 equals 1. Then I divide by everything inside the parentheses to get dy dx by itself, and it's going to equal 1 divided by 3y squared minus 2y minus 1. So when I put 2 in for each one, there's no x left here, right, for me to use a 2. So I literally have 1 over, well, if I put a 2 in for this, that's 2 times 2 is 4. 4 times 3 is 12. 2 times 2 is 4 minus 1, which ends up being 1 over 7, which I believe is the answer that we got. Ignore that. Okay. This is what we're doing. We put 2x plus h squared. X, everywhere there's an x, I'm putting x plus h. Then I have to subtract the whole entire original function. Okay, so I'm foiling this out, and you get x squared plus 2xh plus h squared minus 5 times x minus 5 times h minus 2x squared. Minus times a minus is a plus 5x. Minus times a plus is minus 7. So I can already see that the 7's cancel out. I'm going to take 2 all through there. These cancel. These cancel. And don't forget, over h. Okay, and then this is where on the top I can pull an h out and get 4x plus 2h minus 5 over the h. The h's cancel. We put a 0 in for this h and solve. So we have 4x. 2 times 0 is 0 minus 5. This canceled to a 1. So that's our answer. And if we check ourselves the old easier way, 2 times 2 is 4, x 2 minus 1 is 1 or nothing, and then 1 times 5 is 5. So we can see that we did it correctly. Okay. And from here on out, I think you have everything worked out on Chegg, and you're going to concentrate on the first half. So good luck. You got this.